describe your research for us?
Yeah, so my research is in theoretical particle physics. So the questions particle physics tries to answer is what makes up the universe on the smallest level? So what are the fundamental particles? What are the forces that hold them together? And how does that explain the things that we observe? And that's everything from how atoms work all the way up to trying to explain like why galaxies are the way they are or why the universe has the structure it has. As a theorist, what I do is come up with ideas about what particles could be out there, what forces are there, and how they could explain observations that we see. And then we try and convince experimentalists to go and test them for us and see if we're right or not. Yeah, I don't even know myself how I first got into physics. There's something when I was in high school that it seemed cool. I'd never really taken a physics course, but I had taken some math classes, and I liked that they had these physical applications to them. Um, when I got to university, I actually majored in engineering, and part of the reason was that I wanted to try all sorts of different areas. And what I found was that anything that involved building and designing was not my strong point, but the things that I really liked were the classes where we delved into like how things worked at the fundamental level, like electricity and magnetism or statistical mechanics. And I ended up specializing in physics, and then from there I went on to do theoretical physics, my PhD. My favorite part of physics is having a puzzle that you need to solve. I like working with a prescribed set of rules. So you have something you're trying to explain, and you're trying to figure out why that comes about from some more basic reasoning. And so I like, first of all, that it's open-ended, but it's not too open-ended. And I like trying to explain complicated things in terms of simpler ideas, that we can break a problem down and actually, even in research, if there are ways that we can explain things, for instance, in the way that we talk about physics, say in a first-year college course, then I feel like we really understand what's going on, and I really find that satisfying. Yeah, so many of you may have heard about the Higgs boson, which is this important particle that was discovered that's kind of the linchpin of our current theory. And it played a really important role right after the Big Bang. And what's amazing is that when it was playing this role, the universe, or at least the universe that was observable in size, was only about 2 centimeters long. So if you think about all the stuff that we see crushed into that small distance. But another thing that's exciting about that is that that's something that you can see like in your hand. And so we can actually test the physics of that early stage of the universe with experiments that involve things that are very tangible, that we can touch. So it's this really weird numerical connection between like a day-to-day scale and something that was happening right after the Big Bang. I guess just that there's so many different ways of doing physics. I think when I was in high school, one of the things that made me think that maybe I shouldn't be a physicist is that everyone seemed really interested in like rockets and circuits and kind of blowing things up. And what I later learned is that there's so many different ways of thinking about physics and doing physics. And so I think there's a way that everyone can get involved in physics and be excited about it. Not to like crap on the people who like to build rockets and stuff, but I people are like, oh, do you want to see this thing? I'm like, no, I want to have my book and my like